A very good morning and welcome back to my channel, which is Teacher Cool. So till now in the previous videos or in the previous you can say the chapters, we were talking about the basics about particles, antiparticles, beta decay, neutrinos, antineutrinos, positrons and gamma photons, virtual photons and W bosons, etc. What were the force carriers we were calling them. But now we will be talking about basically quarks and leptons. So what happens is, we know that elementary particles are protons, neutrons, electrons till now, but there are a few other particles also, which you can say these are not particles, but the classification of particles based on their properties, based on their interactions, which we'll be classifying in this chapter, and we'll talk about these properties and their interactions in detail and in a way, as I said, in terms of a family tree ki kahan se we'll start with the classification, first category, then we'll divide and then we'll further divide. So this way, in similar way of a family tree, we'll be doing the you can say these particles or these classifications. So we'll start with the space invaders and how did we come to know about these new particles apart from the proton, neutron and electrons. So we'll start with the cosmic rays. Now what are cosmic rays? See, whenever we are talking about a star or a sun, which is also again a star, these stars, they are always radiating out photons, gamma ray photons or some other radiations also. Now these radiations comprise of a large number of particles. Some of these particles we can detect from our naked eyes, some of them we cannot, some of them we detect them from particular detectors, and even after that there are so many particles which are going undetected by any means which we have till date, that we cannot actually detect them. As in the previous lecture we said that virtual photons we cannot detect them. So similarly, like neutrinos, they say that in a second billions of neutrinos are passing through the earth from the space, but all of them go undetected because they are not interacting at all. So same way, these cosmic rays, they comprise of a large type of these particles. So we call them basically space invaders because the maximum amount of the space is, you can say, is occupied these particles, which are strange in nature, which have been undetected for a very long time, and they show a strange behavior, strange interactions with other particles or antiparticles or among themselves. So we say that cosmic rays which are coming from the stars are high energy particles that travel through the space from stars including the sun. These rays are originating from particular stars and they are traveling in the space. Now when these rays enter Earth's atmosphere or some other planet's atmosphere or some new mediums, they create new short-lived particles which have strange behaviors, which have new masses, which have intermediate masses, intermediate ranges of their lifespan. And these particles are, they can be particles, antiparticles or photons as well, right? So we say when these rays, they enter Earth's atmosphere and they react with molecules or gases or ions which are present in Earth's atmosphere, they interact in a different way and they create new particles out of it. So in general we can say that most of the cosmic rays are fast moving photons or small nuclei, which when they enter some atmosphere or some media, they collide with any of the gas molecules, and from this gas molecules a shower of particles, antiparticles is created, which are then detected at ground level because we are at ground level and we are detecting them through detectors. Now, what are these detectors? These are mainly the cloud chambers. Few of such particles you can say are, number one is muons. These are negatively charged particles and somehow its properties are equivalent to a heavy electron. मतलब electron type इसकी कुछ properties हैं, but its mass is heavier than electron, which is approximately 200 times the mass of electrons. So we call it heavy electrons, and since it is negatively charged, so I'll write mu negative. Now the second one is pions or the pi mesons. I'll tell what are mesons. So right now the name is pi mesons. These are charged as well as chargeless. They can be positively charged, they can be negatively charged, and they can be chargeless also. Now, the mass of these particles is intermediate to proton and muon. So basically electron also. Now, muon का mass is greater than the mass of electron. Then pion का mass is greater than the mass of muon. And similarly, the third one is kaons. Kaons again is a K meson, and the symbol would be K, and again this can have all the charges positive, negative and 0, and its mass will be higher than the mass of pion but always less than the mass of a proton. So proton is one of the heaviest particle here. Now what are mesons? So we say that much before these particles were discovered or detected, the cloud chambers were being used, and the photographic films which were being studied, they showed that before the discovery of above particles, mesons were the basically first particles which were detected, and the way they were detected were the photographic films which are being studied, there were trajectories or tracks which could not fit in the already observed particles. They had different tracks, they had different masses. So we said that they have had intermediate rest masses and short or intermediate ranges. Then around an year later, so meson was the first one. Then around an year later in cloud chamber again, new particles were again detected with comparatively larger range as expected. So first of all, mesons were detected. They had the short ranges. So again an year later, new tracks were detected in the photographs of the cloud chamber. But this time the range of these particles was slightly larger than what was expected from the earlier detected strange particles. Right? So when we studied them further, they showed that these were equivalent to heavy electrons, as I said here. So they named them as muons. But there was again a change. We say that when mesons were studied, it was found that mesons would decay through strong interactions or electromagnetic interactions, but muon was decaying through weak interactions. The result was that it is not a meson. Now, then Yukawa was again a scientist who discovered the microscopic tracks in the photographic emulsions when he detected or took the photographs at high altitudes. That means there were some strange particles which were present at high altitudes but could not reach to the ground levels. So at those high altitudes, the new particles or the new tracks which were detected or discovered were studied further, and the scientists who studied them named them as pi mesons or the pions. So this way these new particles or these new strange particles were detected or discovered, and after they were discovered, they were studied further. Their ranges or their masses were again you can say they were recorded and then compared with other particles, and the results were declared that these are the new strange particles and these are the particular names for them, these are their ranges and these are their properties. But after then again there came a very strange puzzle. Now what is this puzzle? So the strange puzzle is that while this process of discovering these new particles and strange particles was going on, in the same process after the discovery of muons and pions, the only particle which was left was kaons, and while they were discovering or they were in search of this new particles, so what happened is ki in the period of less than an year, again Powell was the scientist this time, he discovered short-lived particles again where in the photographic films of the cloud chamber again, right? and these particles today known as kaons. Now, okay, when we are saying that these particles are strange particles or it is a strange puzzle, that means there is something which could not be explained with regarding these new particles. Now, what was this strange puzzle was? Like, just like the pions which were earlier discovered, kaons were also produced in pairs through strong interactions. This was very clear that pions were always produced in pairs, and similarly kaons were also produced in pairs. How? We say that in the cloud chamber, when there is a high speed protons, high energy protons, they collide with the nuclei. The shower of kaons were produced. We say that here it is the origin point of the kaons, and this process was quite quick and it was through the strong interactions. And ideally it should decay also in the similar time or comparative time, but the observation was that after the kaons were created, they decayed to pions, but comparatively they took a longer time and they were decaying through the weak interactions. So this was a strange behavior that the same particle is getting created by strong interactions, whereas they are decaying through weak interactions, and hence we named kaons as strange particles. Now, all the above new particles can be generated in the accelerators. Obviously, everything was, since everything was discovered in the cloud chamber photographs, so we say that in the accelerators, all the above particles can be created where fast moving protons collide head on with other protons or with some nuclei, where this kinetic energy of this proton is getting converted to the rest masses of these new strange particles. Also, we say that when they are getting created in the accelerators, that means accelerator K controls are in our hand. So we say that whenever we need to study these particles, we can very well study them in the controlled conditions by using these accelerators. And why do we need to study them? Because we need to know their masses, their charges, their lifespan, half-life, etc., plus their antiparticles, and the most important, their decay modes. These are fixed quantities and these are also fixed, but decay modes is a process. These are quantities, but decay mode is a process, and these particles are muons, kaons and pions. So the possibilities of the decay are kaon decaying to pion, then pion further decaying to mu plus antineutrino, which is a muon, or it can decay to antimuon plus neutrino. Again, one observation for you, that every time, whether here or here or here, every time it's particle plus antiparticle, not the corresponding pair, but one result is a particle and another result is an antiparticle, right? Similarly, since kaon has decayed through three modes, we have the pions now. Now pions again are either positive negative charge or they are chargeless. So we say that if the pion is charged, pion will decay to muon plus antineutrino or antimuon plus neutrino. Again the pair. Also the chargeless pion always decays to high energy photons. Now third is muon. Muon is always negative charge, so that means mu negative is my particle and it is decaying to electron particle plus antineutrino antiparticle, or the antiparticle of muon, which is mu positive, will decay to positron plus neutrino, right? So these were the possible decay modes of these strange particles, and when we studied these decay modes, it was also observed that every decay process is following certain laws, and these laws are my conservation laws, which are charge, mass, energy and momentum. Every decay mode or every interaction will follow or will obey these conservation laws at any cost, right? Examples also we'll do when we'll study the interactions. Now what is particle sorting? See, earlier we had electron, proton, neutrons, and now we have three strange particles which are muon, pion, kaons. Also we have W bosons, and we had the virtual photon, and maybe new particles we may come across also. These are the particles and their corresponding antiparticles. So in all, we have a large number of particles now. Now, when we were studying about the elements, or when we were discovering the normal elements in the universe, after a certain period of time, when we knew certain properties of these elements, we needed the sorting of those elements, and it came out to be in terms of periodic table. Yes, the periodic table, so that we can compare, we can make use of them, and it makes us easy to use, and you can say classify. So the same process is required for these particles now, because we have a large number of particles and we know their properties also. There must be some pattern, or there must be some relation, or there must be some sort of this classification which will make it easier for us to remember them. As I said, now by sorting, we are going to make a family tree of these particles. Now, what is the basic need of the sorting is to know how do they fit with themselves, or with another particles, or with the previously existing particles. Also, the few observed properties were they are created through high energy interactions. Obviously, high energy proton ही हर चीज को instigate कर रहा है. Then they decay into neutrinos, antineutrinos, or other particle antiparticle pairs. Charged pions and charged kaons are always produced in pairs, right? And also, since pi positive and pi negative both exist, we say by showing their properties that pi positive is the antiparticle of pi negative, and vice versa. Similarly, K positive is my antiparticle of K negative, and vice versa. So these were the few properties, these were few you can say the results which we came across, and now on the basis of these results and these properties, we are going to sort all these particles, or we can say we'll club them together and we'll make generations of a family tree. What will be this family tree? We'll bring back in the next video. For this video, this was all. What are strange particles? How were they discovered? What are their few properties and their interactions? For the next video, stay tuned. If you want to know the family tree of these strange particles, we'll be back very soon. Until then, do like, share, subscribe to my channel, which is Teacher Cool. And if you have any doubt, for sure leave in the comment section. I will definitely revert back, right? So see you soon again. Till then, goodbye.